Think about everything around you, trees, rocks, even your own body. It's amazing, but it all started with a bang. I mean, a really big bang, the Big Bang. About 13.8 billion years ago, our entire universe was crammed into a tiny point, smaller than an atom. Suddenly, boom, the universe exploded outward, expanding and cooling. This wasn't an explosion like dynamite in space, though. It was space itself stretching, creating room for everything to exist. As the universe cooled down after the Big Bang, tiny particles started to clump together. These particles formed the first atoms, the basic building blocks of everything we see. The most important atom was hydrogen, the simplest and most common element in the universe. Over millions of years, gravity pulled huge clouds of hydrogen together. These clouds became so dense and hot that the hydrogen atoms began to fuse, releasing enormous energy. That's how the first stars ignited, lighting up the early universe. Stars are amazing cosmic factories. They don't just make light and heat. Inside their super-hot cores, stars fuse hydrogen into heavier elements like helium, carbon, and oxygen. These elements are crucial for life, and without stars, they wouldn't exist. Eventually, some stars run out of fuel and explode as supernovas. These spectacular explosions scatter the elements forged in their cores far and wide, seeding the universe with the ingredients for planets and even life itself. So the next time you look up at the stars, remember, we are literally made of star stuff. About 4.6 billion years ago, in a quiet corner of the Milky Way galaxy, a giant cloud of gas and dust started to collapse under its own gravity. This cloud, called a solar nebula, contained the remnants of countless supernovas, including all the elements that would eventually make up our sun and the planets. As the nebula collapsed, it spun faster and faster, like a spinning figure skater pulling in their arms. Most of the material got pulled into the center, forming a hot, dense protostar, the baby sun. The remaining gas and dust swirled around the protosun, forming a flat disk. Within this disk, tiny particles of dust and ice collided and stuck together, a process called accretion. These clumps grew bigger over time, attracting more and more material. Eventually, they became planetesimals, the building blocks of planets. In the inner region of the disk, closer to the young sun, it was too hot for volatile substances like water and methane to condense into ice, so the planetesimals here were mostly made of rock and metal. These rocky bodies collided and merged, eventually forming the inner rocky planets: Mercury, Venus, Earth, and Mars. Further out beyond what we call the frost line, it was cold enough for volatile substances to freeze. As a result, the planetesimals in the outer region were much larger and richer in ices, along with rock and metal. These icy giants continued to grow, eventually becoming the gas giants: Jupiter, Saturn, Uranus, and Neptune. Our solar system, with its diverse planets and unique characteristics, was born from this chaotic and beautiful process of cosmic evolution. Imagine the early Earth. It was nothing like the planet we know and love today. Instead of lush continents and vast oceans, the surface was a molten hellscape bombarded by asteroids and comets. This period, from Earth's formation about 4.6 billion to 4 billion years ago, is called the Hadean Eon, named after Hades, the Greek god of the underworld. And for good reason, because early Earth was a true inferno. The energy from all those collisions, along with the heat released from radioactive decay within Earth's interior, kept the surface molten for millions of years. Volcanoes erupted violently, spewing lava and gases into the primitive atmosphere. There were no oceans yet, only superheated steam and clouds of silicate vapor. The sky would have glowed an eerie red, and the air would have been thick with noxious gases. It was a time of intense heat, constant bombardment, and unimaginable violence. But amidst this chaos, something incredible was happening. The constant bombardment of asteroids and comets, while destructive, also delivered something crucial to Earth: water. Locked within these icy bodies were vast amounts of water, along with other volatile compounds. As they crashed into Earth, they released their icy cargo, gradually accumulating in the atmosphere. Over millions of years, as Earth slowly cooled, this steam condensed and fell as torrential rain, forming the first oceans. These early oceans were probably acidic and hot, nothing like the life-giving waters we know today. but they represented a turning point in Earth's story, setting the stage for the emergence of life itself. The early Earth was far from hospitable, yet in this harsh and alien environment, life somehow emerged. The exact details of this miraculous event remain a mystery, but scientists have some intriguing theories. One prominent idea is that life arose in volcanic hydrothermal vents deep beneath the ocean's surface. These vents spew out hot, mineral-rich water, creating chemical gradients that could have provided the energy for the first life forms to emerge. Another theory suggests that life began in shallow pools of water on the early Earth. These pools, bombarded by ultraviolet radiation from the sun and energized by lightning strikes, could have acted as primordial soups, where organic molecules assembled into the building blocks of life. Regardless of where it began, life found a way to take hold and thrive in the face of adversity. The first life forms were simple, single-celled organisms similar to bacteria. They were likely extremophiles adapted to survive in the extreme conditions of early Earth. These early microbes were pioneers, paving the way for all life that would follow. They released oxygen into the atmosphere through photosynthesis, gradually transforming the planet and setting the stage for the evolution of more complex life forms. The journey from those humble beginnings to the incredible diversity of life we see today is a testament to the power of evolution and the remarkable resilience of life itself. From Stardust to Earth, it's an epic origin story, billions of years in the making, a story that continues to unfold even today.